Good morning, good afternoon, good evening, wherever you are in the world. My name is Ali Reza Moqayyedi and I am a Senior Research Officer at the University of the Cape Town. Today I am presenting causality between the challenges, motivation and extent of use of water recycling system in residential properties. This is one of the outcomes of the international collaborative research founded by the Royal Academy of Engineering under Frontier of Engineering for Development program. Cities around the world face growing threats of urban water shortage due to climate change, population growth, and urbanization. More than half the world population already lives in the cities, and the portion is forecasted to grow towards 66% by 2050, which means 2 billion extra inhabitants need water. Globally, at least 30% of the fresh water used in the buildings. A local research is just shows 63% of the water used in the city of the Cape Town by the residential property. Sustainable water management will help ensure reliable water supplies today and for the future generation. As we just show, residential property consume a big portion of the fresh water in the urban area. Therefore, water recycling in residential property is an essential aspect of the sustainable water management. Understanding how communities and households engage with the water management and water recycling can provide a necessary foundation to inform initiatives required to change behavior or build support for a new policy or investments. However, there is a limited knowledge about the drivers of adopting water recycling system in residential property, especially in the global south. Furthermore, there is no research to evaluate the causality and impact of these drivers on the extent of the water recycling system in residential property in the global south. Furthermore, no academic evidence that houses' characteristics and the residents' awareness influence the extent of the water recycling system in residential properties. Exploring opportunity and enhance the extent of the water recycling in residential property in the global south face several challenges because of this knowledge gap. The objective of this research is to examine the influence of the house's characteristics, micro motivations, and the challenges on adopting water recycling system in the middle-income residence properties using the causality model. This research is aimed to provide a broader socio-economic understanding of water recycling adopting in the middle-income household and evidence-based approach to enable professionals to target engaging tools to promote water recycling in residential property in the global south. To collect the primary data cross-section of the lower to upper middle income country in the global south, the following 5 case study was used: Kuala Lumpur, Malaysia, Michoacan, Mexico, Ota in Nigeria, Panama City in Panama, and the Cape Town in South Africa. A structured questionnaire was designed, included the following 5. Through the extensive literature review, we identified 3 independent constructs of the model: houses characteristic and residents awareness, motivation on adoption of the water recycling system, challenges on adoption of the water recycling system. Also, the literature review showed the different variables for each of these constructs as listed in that table. 3 hypotheses theoretized to just show the relationship between the construct and output of the causality model. Hypothesis 1, there is a relation between the house characteristic, residents' awareness of the water recycling system, and extent of the use of the water recycling system. Hypothesis 2, there is a relation between the motivation for the adoption of the water recycling system and the extent of the use of water recycling system. And the hypothesis 3, there is a relation between the challenges on the adoption of the water recycling system and extent of the use of water recycling system in residential properties. Besides the direct relationship, two indirect relationships hypothesized to just show the relation between the inputs and the output of the causality model. Hypothesis 4, there is a relationship between the house characteristics, residence awareness, motivation on the adoption of the water recycling system, and the extent of the use of water recycling system. And finally, hypothesis 5, there is a relation between the house's characteristic, residence awareness, challenges on adoption of the water recycling system, and the extent of the use of water recycling system in residential properties. Finally, the 5 theoretized hypothesis is just integrated to the model. 3 direct relationship and 2 indirect relationship showing the relation between the inputs construct and the output of the model. 684 completed questionnaire completed by the middle income property residents across the 5 case study used to develop the purpose causality model in the Smart PLS software. As shown in the path diagram, all loading factor of the identified variables are greater than the 0.7, which we use all the identified variable to model the relationship between the identified construct and the variables. As listed in table 1, the result of internal consistency, composite reliability, and convergent validity test prove that the collected data have a high satisfactory validity and internal consistency. Prior to analyzing the causality model, 5 hypotheses were tested using t-statistics. P-value of the hypothesis tests are less than 0.05. Therefore, all 5 research hypotheses are statistically significant as presented in table 2. The outer weight of the variables are estimated and the results are ranked according to the relative importance. The results show awareness of the water recycling system is the most important variable under the readiness and awareness construct. Type of the house and availability of the space for installing water recycling system are the other most important variable in readiness and awareness construct. Therefore, considering the strong positive impact of the readiness and awareness construct on the extent of the use, the variable under this construct have the most influence on the extent of the water recycling on houses. Protect environment, cultural practice, and conservative of the water are the predominant variables under motivations construct, which indicate the importance of the environmental and social motivation on the adoption of the water recycling in the middle-income residence properties. On the other hand, lack of information or awareness on availability of technology and no clear saving on water payments are the challenges with the most negative effect on the extent of the use of water recycling system at houses. Overall, the outer weight of the variable of the 3 constructs of the causality model are very close together, which validate the importance effect of all selected variables on the extent of the use of recycling water in middle-income house in the global south. The analysis of the motivation data show the water bills and the water conservation are the primary motivation for adopting water recycling scheme in African houses. These motivations are directly linked to the African lower middle income economic and environment context. However, in Malaysia and Mexico, protecting the environment is the highest motivation for the adoption of the water recycling, while the second motivation is conservation of the water in Malaysia and drought in Mexico. In Panama, as the country with the most adopted water recycling system in the middle-income residents' property among the other case studies, cultural practice is the predominant motivation for using water recycling systems. This finding clearly has proved the crucial role of the socio-cultural in promoting water recycling system in households. On the other hand, the findings obtained from the analysis of the challenges
on using water recycling across the 5 case study proved that the capital and operational costs, no clear saving on water payment, lack of information or awareness, and unavailability of the technology are the most micro challenges on the implementation of the water recycling scheme in the middle-income residential property in the Global South. Finally, as a conclusion, the study validates the causality model of the water recycling system by empirically examining relationship between the house's characteristics and residents' awareness, motivation, challenges on adoption of the water recycling, and extending the use of the water recycling in the middle-income houses in the Global South. The findings from this study have shown the negative impact of the micro challenges on implementing water recycling system will be significantly reduced by improving water recycling system efficiency and availability. Also, the extent of the use of the water recycling in residential property will increase with the cultural practice and awareness and education of the homeowners. The study concluded that the acquisition of the basic environmental and technical knowledge associated with the water recycling and the government incentive for implementing water recycling system in residential property are the mechanism to enhance the implementation of the water recycling system in middle-income households in the Global South. The finding of this study assists in developing a data-driven decision-making framework to build capacity for the analyzing of new water reuse intervention strategy commensurate with the capacity and resources of the urban authorities and communities. Moreover, local, national, and international water practitioners can use the causality model to understand the readiness of the houses, awareness of the people, motivating or the challenges factor likely to drive the homeowners' intention to adopt and use the water recycling system in their houses. Thank you very much.